What is the absolute value of -2? What is the absolute value of 5? What do you notice about both of these answers? They are positive. Absolute value is always equal to a positive number. This is because absolute value represents distance from 0. I have a really awesome co-teacher who explained this to my Algebra B students, saying, so if I run 2 laps on the track, how many laps have I run? 2. But what if I run 2 laps backwards? How many laps have I run? 2. So absolute value is always the positive version of the number because it represents distance. 5 is 5 units from 0. -5 would also be 5 units from 0. So it's how far that number is from 0. So number 1, the absolute value of x equals 6. We need to have a solution that tells us what x values are 6 units away from 0. So what's one number that's 6 units away from 0? 6. Is there another number that is 6 units away from 0? -6. So notice there are 2 solutions to this equation. X can equal 6. X can also equal -6. Both of those x values are 6 units away from 0. So now we look at number 2. And for number 2, I'm actually going to do this problem up here because I don't think we have enough space down there to do it. This time, the stuff in the absolute value bars is a little bit more confusing. But that 3x plus 1 has to be a value that is 5 units away from 0. Where on the number line are we 5 units away from 0? At 5 and at -5. So we write 2 equations. 3x plus 1 could be equivalent to 5. 5 is 5 units away from 0. Or 3x plus 1 might be a value of -5 because -5 is also 5 units away from 0. We need to solve both of these equations, so let's solve both of them. Subtract 1, we get 3x equals 4. Divide by 3, x equals 4/3. Do the same process over on the right. If I were to plug in 4/3 into this original equation, 3 times 4/3 plus 1 would give me a value of 5. So I would have the absolute value of 5 equals 5. That is a true statement. That solution works. If I plug -2 in, what is 3 times -2? -6, and -6 plus 1 is -5. Does the absolute value of -5 equal 5? Yes, so that solution also works. Absolute value equations often have 2 solutions. So here, I'm just going to draw an arrow up here so we know that we did that problem up there. So number 3, the absolute value of 2x minus 12 equals -4. Where are we -4 units from 0? Some of you are thinking 4 and -4, right? But take a look back up here where we first started talking about absolute value. What does absolute value always have to equal? A positive number. Does this absolute value equal a positive number? No. So notice the directions say solve each equation if possible. It is not possible for an absolute value of something to equal a negative number. No matter what x value you get, if you plug it in there, would the absolute value of whatever that number is equal -4? No, not possible. This would be no solutions. Honestly, you hope for these because then you can just write no solutions and you don't have to do any work and you move on. Number 4, when we first look at it, we see that it equals a negative number. And you might be thinking, oh, no solutions, I don't have to do any work. But what looks different about number 4 compared to the other problems? There's that minus 10. All of our other equations have had absolute value by itself on the left. So our first step in number 4 is going to be to add 10 on both sides. Why do you do that, screen? Why? Plus 10. So the absolute value of 3x plus 9 is going to equal 6. What two equations would we set up to solve this? 3x plus 9 equals 6, and 3x plus 9 equals negative 6. Do you all feel fairly confident that you could solve both of those equations and get the two solutions? All right, moving on then. Next page. Oh, before we turn to the next page, you don't have to write this in your notes, but I want you to at least see it and consider it. So I'm going to write consider, and I'm going to kind of make up a problem here. Okay. What do you think that you would do first in the process of solving this absolute value equation? Add the 4. So 2 times the absolute value of x plus 5 equals 14. You would divide by 2. You cannot distribute into absolute value bars. Absolute value bars don't work like parentheses, so do not try to distribute. In fact, you may want to write at the bottom of your notes, do not distribute. Instead, you would divide both sides by 2. Now, I saw some students in my last hour doing this, and they tried to divide everything by 2. When you divide the left side by 2, all you're doing is canceling out that 2. So you have the absolute value of x plus 5 equals 7. Then you would set up your two equations and solve both equations. All right, next page. At the top of the page, there's a little reminder. If you have absolute value equals a positive number, that means you're going to have the potential for two solutions. If you had absolute value equals 0, where on the number line are you 0 units away from 0? At 0. There aren't two possible places, there's just 0. So that type of problem, you would have one solution. If you have absolute value equals a negative number, that isn't possible, so there's no solutions. When there are variables on both sides, we must consider the potential for extraneous solutions. Now, I know that you've seen that term before. Do you remember what it means? Let's break it down. What are the first 5 letters of the word? Extra. Extraneous solutions are extra solutions. So in the process of solving these equations, we may end up with two solutions. Because there's a variable on the right side, there's a chance that one of those solutions doesn't actually work. It appears to be a solution after solving the problem using correct mathematical methods, but when you plug it into the original problem, it doesn't actually work. So here's how we do problems with variables on the right side. We have the absolute value alone on the left. So x is going to equal 2x plus 3. That's my first equation. The first equation is basically exactly what you have written without the absolute value bars. The second equation, the stuff in the absolute value bars equals, anyone want to take a guess what the other side's going to be? Negative 2x minus 3. You basically have to multiply everything on the right side by negative 1. Flip everything opposite on the right side. Okay, take a moment, solve both of those equations. Notice there's x's on both sides, so if you're tempted to subtract 3 on both sides, that's not the step that I would take. Okay, so I solved both. I got x equals -3 and x equals -1. We are supposed to check for extraneous solutions. Now, if you check each of these in the equations they came from, they are going to work because that's where the solution came from. Don't check it here. Check it here. Check it in the original problem. So plug -3 in where you see the x. So inside the absolute value bars, we would have -3. On the other side, we can kind of use mental math or beep, bop, boop in our calculator to get our calculator to tell us what it is. 2 times -3. What is that? 2 times -3? -6. -6 plus 3? -3. Now, think about that statement. Is the absolute value of -3 equal to -3? No. So that is an extraneous solution. Cross it out. So particularly when you get negative solutions, you really want to make sure you check. This is a big enough, well actually small enough, but this negative solution creates a negative number on the right side and absolute value can't equal negative. Now let's check the 1. Absolute value of -1. Let's plug -1 in on the other side. 2 times -1 is -2. -2 plus 3 is 1. Does the absolute value of -1 equal +1? Yes, it does. So you can box that solution. X equals -1 is the only actual solution. -3 is an extraneous solution, an extra solution. Okay, number 6. Let's set it up together. Our first equation would be 2x minus 4 equals x. Exactly what we're given, just without the absolute value bars. What's my other equation going to look like? Close. You don't change the left side at all. Don't change the side that's in the absolute value bars. So stuff from the absolute value bars, 2x minus 4 equals -x. You only change the side that doesn't have the absolute value bars. Okay, take a moment, solve both of those, and then see if you can start checking your solutions in the original problem. Okay, so I solved both of them. I got x equals 4 and x equals -4/3. Is that what you got? The x equals 4 should be really easy to plug in. So 2 times 4 is 8. 8 minus 4 is 4. So inside those absolute value bars, we would have a 4. And x, put the 4 in place of that x, is the absolute value of 4 equal to 4? Yes, that solution works. Now the solution of 4/3 is a little bit more challenging to plug in, especially if you aren't very comfortable with fractions. So I'm going to use my handy dandy calculator, if it takes a moment to load. Maybe. And I still have this in here from before, but I did 2 times 4/3 minus 4, and I got this, which is the decimal -4/3. So the inside of my absolute value bars should be -4/3. Trying to make that fit on the page. I don't think it's going to. And x is +4/3. Does the absolute value of -4/3 equal +4/3? Yes, it does. So that is also a solution. So the purpose of these notes is to show you that you might have one solution that works, you might have both solutions that work, and sometimes in rare cases you might end up with both solutions not working, in which case it'd be no solution.